So we can have a question answer session because there was no question during the discussion.
Aroha, please.
Good afternoon, everybody. Sir, thank you very much for your insightful presentation. It was really a great learning. And so we would just like to start with the questions. So anybody would like to ask a question?
There are some questions in the chat box.
Yeah, so from chat, we will start the question from Mr. Pramod. What is exact difference between reactors addition and putting active filters in circuit?
The reactor and active filter. A reactor is a part of the passive mitigation system. Passive harmonic mitigation is done by the reactor. It has limitations. Means we are targeting normally mainly one harmonic at a time, say 7% or 5.69%. When we are putting a reactor, we are taking care of mainly fifth harmonic and to some extent seventh harmonic and higher order harmonics. But it is very limited. The impact, the result, we still may have harmonics left out because if the percentage of harmonics, the load is very bad, the spectrum is poor, we may have some other harmonics. So then this passive filter is not sufficient, and it may need some further augmentation with the active filter. So active filter either independently or as a addition to the passive filter, we use active filter. So whatever is left out, not filtered by the reactor combination with the capacitor, that we do it with the active filter. And it is always good that first we try to mitigate as much as possible with the passive because that is the cheapest in both ways. One is that cost wise, as it is cheaper, the combination of reactor capacitor and APFC. And secondly, because we have to put APFC in any case, most of the people have APFCs. So when they are putting APFC in any case, so let it be designed properly and let us try to get maximum out of it with some filtration also. And some places we have seen that we have done the entire filtration with only passive, no active was required because mostly we have 6 pulse converters in the loads. The only fifth and seventh harmonics are the present harmonics, and they can be very easily tackled with the passive itself. So maybe we can avoid active filter totally. But whenever it is required, we can, whatever is the remaining harmonic left out, whatever amperes are required, that much active filter we can add later on, where we generate the frequencies are 180-degree out of phase with the active harmonics present, and then we inject into the system and we kill that harmonics.
An add-on question from my side. First of all, what is design life of active filters generally? In your experience, how much do they last, and what is the maintenance cost as compared to capacitor banks? And secondly, what is the self-consumption of those active power filters, or as you called SVG? So as compared to the loss that we are suffering currently because of improper power quality as well as power factor.
The life, as you said first, life today, these systems are very mature. The systems, there are no, you can say, recurring maintenance problems, not much of failure. Initially, when these active filters came in the country, it was when Tamil Nadu introduced the regulations, 15% penalty. Hello?
Mr. Jagtap, can you please mute your audio? Mr. Ganesh Jagtap, thank you.
So when initially when these active filters came into the market was during Tamil Nadu when they introduced penalty, 15% penalty on the harmonics beyond IEEE 519 norm, means 8%, beyond 8% there was a penalty. So active filters came into the market and there were assortment of manufacturers without much experience without much, you can say, development proper, and almost majority of them failed. So that was the situation maybe about 7 8 years or so back. But today it is a very mature technology. There are hardly any failures. Most of the manufacturers have upgraded, improved their designs, their quality, and the failures are nominal only, and they are as good as passive, as robust as passive filters today. And the loss wise also, it's not very high. Like Statcom, I said, it is about 1% is the self consumption. In this also, it could be between 1 or 2% only. LT side, whatever we have indigenous as well, without water cooling even, low capacities. And only thing is these active filters, what we have today in the country, they are on the low voltage side. We connect up to maybe 680 volts only. And if we have to mitigate harmonics, because harmonics measurement is done at incoming supply at 33 kV or something. So there, the loads are also there, HT loads are as well. So when we have to mitigate higher harmonics at higher voltages, so these filters are not very effective, and maybe we have to connect them through a transformer, and the cost increases. Like when we are to connect, we have done it at some places, like in Mukan Steel. There we have connected a transformer, and a special transformer has been taken only for filtration. There is no load on that. And LT side, about 750 volt, we have connected the active filter, and primary side is 33 kV, and it is mitigating the harmonics at higher voltage where it is being measured. So to reduce the cost, optimize the cost, because otherwise we have to do it at every voltage level, every bus and all. So the cost is very high. But here again, when we have to put a transformer, the cost again also is very high. The space requirement is there, and that way. But now there is a solution that what we have given at Lloyd Steel, we have given a solution directly at HT. So there is no transformer in between. The IGBT design of the active filter is Statcom or active filter, both the same thing is there. We can have filtration as well as the reactive power compensation, and we have given it at higher voltage itself. For industries, we are giving it at maybe whatever is their voltage, 11 kV or 6.6 kV. And for renewable, mostly they are at 33 kV.
May I know one more thing about it? This is Tushar Moguri speaking. Sir, I wanted to know what is your experience about the watt losses in the static power compensators and as well as active harmonic filters? Because as we understand, can you publish some figures on that particular thing? Because what we have got the figures as 2-level inverters are working at 95% efficiency and others are 97% efficiencies. So basically only 1% losses, then it is a good inverter, what I suggest. But then if we have to use the inverters in our projects, then it would be good that if these results are published actually about the working losses.
Different manufacturers, they have their data sheets. They are maybe the LT side, the manufacturer, what we have, they are giving between 2%, 3% and all. What you said is correct. But what we are supplying at high voltage directly, including the water cooling, that is a big system. There it is less than 1% at 33 kV level, or maybe whatever 6.6 kV also the same thing. But the low voltage side, what we have in India is, it is still about 3%, you can say.
Okay. So this is for HV about 1%, and
about
for LV side
1% is directly HV construction, where the mitigation is done directly at HT level.
Thanks a lot. Thanks.
So coming to next question, this is about solar. So how serious is the issue of power quality from your experience in integrating solar rooftop with local grids? We come across conflicting literature. Some arguing it is being taken care by inverters, while others demonstrate a tangible impact on DISCOM.
There is an issue because all these solar inverters, they generate harmonics also, and they generate very difficult harmonics. But rooftops, we have not seen much of a problem. It is basically where we are integrating with the grid. There is no problem in this rooftop for the grid stability and all those major issues. But we had faced one problem in one of the industries, metal industry. There they had put about 30 kilowatt plant, small rooftop plant only. and they were not able to run. The harmonics were in the range of maybe about 70%. And because they were having the in-house load as well as the solar inverter was also there. So the system was lying idle for almost a year. So there we had given a standard active and passive systems for the load itself, and it was able to work there. Otherwise, when we are having a load and the load itself is non-linear today. So there is you can say export of harmonics from this rooftop. Even the domestic load today is non-linear. So whether you have a domestic or commercial, there will be some harmonics, and if they start questioning and they start measuring that you can't export to them more than 8% or IEEE 519, then most of them will need some solutions like they need it in industries also.
So one more question related to solar. So many places we have seen that after installation of solar power plant, the power factor has reduced. So, or the existing APFC has become insufficient. Whereas the inverter manufacturer claims that the inverter operates at unity power factor. So it is not absorbing, they mean that they are not absorbing any reactive power from the system. So can you please shed some light on this?
The inverter basically is like a statcom only. It can generate reactive, and in fact, in Australia, they used to have inverters 40% higher capacity than the required, because 40% reactive power support also was to be supplied by the inverter only. And inverter can supply reactive power, it can supply active power both. It is designed to do that thing in addition to the active power. So it is depending on how we configure the inverter. We can take the reactive power. We need not take any reactive power from the inverter. We can use it only for just transferring the power and active power only. But your power factor basically for the load, suppose you have an in-house load. So inverter you have to take as a neutral item, that it is, you are not taking anything reactive power, either consumption or supply from the inverter. You have to take as it is, whatever you are doing now with the load, same thing you have to do with that also.
Okay, sir. So just going to the next question from Mr. Santosh, how we can reduce transmission loss in wind energy? We observe high loss when in low wind season, when DFIG is not in operation. In high wind season, when DFIG is in operation, there is low transmission loss. Please guide.
We had one problem was referred to us for a wind plant only, this high wind and low wind conditions only. And the grid conditions, they are not able to follow the grid parameters. And if we have to give a solution, the solution is enormous. It is not viable commercially to give a solution. So there is a problem of voltage, you can say support required. Basically, they need a voltage support, and that is, if it is available, okay. Now, because all these wind plants, they are coming out with at least 33% support. So I don't think there should be a problem in that. Earlier, because as I said, earlier wind plants, solar plants, they came without any support. They were depending totally only on the grid support for the voltage. Voltage means only ultimately power factor, and voltage is same thing. So if we have a reactive power support available sufficient, whatever is required at the location, at the grid parameters are there. Suppose grid also is very weak at that point, and this also is not having any voltage support, there will be a problem.
So one question from Mr. Shirish Afale. Please explain how harmonics mitigation in the renewable and explain PPC.
What is the next thing you told? EPC.
PPC
power plant controller. This basically it controls the operations of the power plant. What I referred it in one connection only, because when there is a fault and the system is not able to continue operation, the inverter goes into oscillatory mode, it trips the system, and the power point is PPC is the first item which ceases at that time. So it is of no use there. So we have to, that's why I referred it in connection with the STATCOM, that we have to have an immediate LVRT compensation, and we maintain the voltage immediately as soon as it is lost before the system goes out of synchronization.
I think that's all with the questions.
I just want to drop in for a minute. Sunday. Hello, Narang Saab.
Yes, sir.
Thank you very much for your very nice explanation. After a long time, it was a more technical sort of a discussion today. Because some of the participants may not be so very versed with the power factor compensation and also the reactive and active compensation. But you explained it in a very simple manner, in a very simple language. So I think it was very much appreciated by you. As I have been saying, I know him for many years, and I found that there is a tremendous clarity in not only in his speaking, but also in his thought. So whenever there is a question raised to him, I think the answer was always there. And I'm sure that those who still have some questions or those who need advice, I have put his email ID on the chat box. They can always refer to him. Of course, they will be also getting, all the participants will be getting this presentation. So that way, that is going to help us. But really, this today's lecture was a knowledge series. A lot of knowledge, I think our participants have gained. Was not only an information about these things, but also more in-depth knowledge about the power factor compensation, about the effects of various harmonics, and so on. So it was a truly a knowledge lecture session, and I'm sure that Mr. Narang will be also available to us, in future for his next presentation, maybe a year or 2 years later on. So I think that's all from my man. Thank you very much again for speaking to us from US. Now it is almost about I suppose it's about 1:30 or so in US. So it is pretty late night, but extremely thankful to you for that.
Thank you, sir.
Over to you, Aroha.
Sir Narang sir.
Yes, sir.
Sorry to disturb you. Can I ask one question after all this?
Yes, sir.
Or upload?
I promote this. I would suggest that we are already a bit late. So let Aroha please request Mr. Chauhan to conclude.
Okay.
Pramod Deshpande, you can talk to him by mail.
Okay, you can note down my phone number, or you can send me a WhatsApp
phone
message.
Phone number would be better.
Phone number you can note down 7719996868.
Just a minute. 77
1999
1999
6868.
Okay, sir. Okay.
You can send me WhatsApp on this, and we can have a conversation. And thank you, Gandhi sir, for this giving me an opportunity to interact with such a good, you can say, number of participants. It was very
Mr.
interesting
Chauhan
to talk to them.
Will conclude. Mr. Chauhan is yet to conclude, sir.
Achha.
Chauhan will conclude and also give vote of thanks.
Okay,
Please,
sir.
Extremely sorry, sir. It's the 77199
No, 771999.
Oh, thank you.
On behalf of Prerna Energy Society and the EKLS series, which we are conducting since last year, I extend my heartfelt thanks to Narang sir. He has taken really physical and other efforts by staying late in the night and then giving us a good dose of knowledge. Formal thanks are already done by Professor Gandhi. So without wasting any time, I will thank all those participants who have attended it. In spite of being Sunday, everybody took time, almost 2 hours for this particular section. So with this, I conclude the session.